Hello, or today's video is about hierarchical reinforcement learning. Hierarchical reinforcement learning, abbreviated as HRL, is an extension to traditional reinforcement learning that incorporates hierarchical structure into the learning process. Unlike the standard reinforcement learning, where agents learn a policy to map a state to action, in HRL, we have agents that learn multiple level of policy. I emphasize here, we have multiple level of policy, each level corresponding to different level of abstraction. Okay, we have multiple level of policy, each corresponding to different level of abstraction. My name is Yusuf and I am going to present this video. Here you see the outline. We discuss key components of HRL, advantage of HRL, application of HRL, challenge and future direction, and finally present the reference. Okay, what are the key components of hierarchical reinforcement learning? Hierarchical policy is the first component in HRL. Policy are organized hierarchically with higher level policy determining which subtask or lower level policy to activate. Okay, the high level policy, low level policy. High level policy determine which low level policy should be activated. Lower level policy focus on achieving a specific goal. They chasing a goal until achieving to this goal, and this goal is set by higher level policy. Okay, so we have high level policy, low level policy. High level policy activate the low level policy and enable them to achieve a goal. We have option framework that provide a structured way to break down complex decision making tasks into a smaller, more manageable subtasks. We have subgoal discovery. Subgoal act as an intermediate milestone that the agent needs to achieve on its way to accomplishing the overall task. Okay, imagine the subgoal as an intermediate milestone. Okay, effective subgoal discovery can significantly enhance the performance of the HRL algorithm. This is very important. And finally, the last component is reward shaping. In HRL, reward shaping involves assigning reward at different level of hierarchy. We have different level of hierarchy, and reward shaping involves assigning reward to this level. Okay, and this reward naturally guide the learning process of the agent. So overall, we have four key components: hierarchical policy that comprise high-level policy, low-level policy, and we have option framework to understand how to break down the complex problem, and we have sub-goal discovery, imagining them as intermediate milestone, and we have reward shaping. Okay, what are the advantages of hierarchical reinforcement learning? The first advantage is scalability, the second is transferability, the third is improved learning efficiency, and the last one is enhanced interpretability. Okay, but let's discuss the first one, scalability. By decomposing complex tasks by decomposing complex tasks into a smaller, more manageable subtask, HRL improve the scalability of RL algorithm. Okay, we divide complex tasks into simpler ones, and therefore we address the scalability in RL algorithm. This hierarchical decomposition allow for more efficient exploration and learning in large state action space. Okay, for example, in robotic, in unmanned aerial vehicle, we have large state and action space. We need to manage them, and this hierarchical decomposition allow for more efficient exploration and learning in such a large space. The second advantage is transferability. HRL facilitates the transfer of knowledge across different tasks. Once a subtask is learned, the corresponding policy can be reused in other tasks. Okay, when we learn a subtask, the obtained policy, the corresponding policy, can be reused in other tasks that have similar context, that have similar subtasks. This is what's referred to transferability. Okay, this transferability reduces the need for learning from scratch in a new environment. And the third advantage is improved learning efficiency. HRL hierarchical structure enable more efficient learning by focusing on a specific subtasks. When we focus on a specific subtask, we have a more efficient learning. And the last advantage is explainability. The hierarchical organization of policy in HRL make it easier to understand and interpret the agent decision making process. Okay, we can better understand the decision making process of an agent using HRL because the task is multiple level and we can better trace it. Okay, each level of hierarchy corresponds to a different level of abstraction, as I pointed out in the beginning slide, providing insight into how the agent approach the overall task. Okay, so overall, what are the advantages? The first advantage is scalability. We can decompose complex tasks into a smaller one and therefore address scalability. The second advantage is transferability. We can, when once a subtask is learned, the corresponding policy can be used in other tasks that have a similar context. Uh, we have improved learning efficiency, um, and also we have enhanced explainability. Okay, what are the application of hierarchical reinforcement learning in artificial intelligence? The first application is robotic. For example, in unmanned aerial vehicle, we have usually very large state and action space. We have trajectory in a state space. We have a large state space. We have large action space, and we can use this hierarchical reinforcement learning to manage this large state and action space. Also, the second application area is natural language processing. HRL is employed in natural language processing tasks like dialogue system, where the agent must manage multiple level of conversation. Okay, the agent must manage multiple level of conversation. In such a case, we can use HRL. In gaming, in video game, HRL is applied to create AI agents that can handle complex strategy by breaking down the game objective into a smaller goal. Okay, and also HRL has application in healthcare. Okay, what are the challenge and future direction? Uh, the first challenge is subgoal discovery. Automatically identifying meaningful subgoal remain a significant challenge in HRL. Okay, I think this is clear. Automatically identifying meaningful subgoal remain a significant challenge in HRL. We have complexity of hierarchical policy. Designing and learning hierarchical policy can be computationally expensive and require significant tuning. I think this is obvious. We have multiple levels, and therefore designing and learning hierarchical policy is computationally expensive. We have integration as a future direction. We have integration with deep learning. Integrating HRL with deep learning technique is a promising direction, but also present challenge such as managing the increased computational demand and ensuring a stable learning. Okay, so we have challenges such as subgoal discovery, complexity of hierarchical policy, and we have the integration with deep learning as a future direction. This link is my reference. Thank you very much. If you learned something from this video, I appreciate you like and subscribe.